And you know, they're always talking about what came first, the chicken or the egg. Whoa! When we start thinking about Colossal, you guys are able to genetically edit the chromosomes, essentially. Correct?
Yes, yes.
And you can make a giant moa. But I think the big question that everybody's gonna have is why? Today I'm at Bellowing Acres Wildlife Sanctuary, where I'm getting up close with the emu to understand how its genetic blueprint is going to help us de-extinct the giant moa. And hopefully, I won't be getting kicked in the face.
Joining me today on this interactive emu walk and talk is Colossal Biosciences top avian expert, Dr. Anna Keat. And stay tuned, because after we talk turkey, we're flying straight to their state-of-the-art facility to learn exactly how they plan to bring this genome back to life.
I can't even imagine, like, dude, a bird dropping an egg like this? Ouch, that seems like that would be a lot. So what ultimately drove the giant moa to extinction?
When Polynesians arrived on New Zealand, it was a great food source. And prior to that time, they hadn't had any contact with humans. So it was hunting and loss of habitat.
Which gives great justification for why we want to de-extinct this species.
Yeah, we think so.
Okay. And when did the giant moa disappear off the face of the planet?
Just a few hundred years ago.
Okay, so as I read, it was like the late 1400s, right?
Yeah.
And this is a species that was native to the South Island of New Zealand, when we're talking giant moa. But the emu is an Australian-based bird, so close enough in the general vicinity for this to be a good advocate for the genetic work that's going to be done to de-extinct the giant moa.
That's right.
So these are big birds. When you think about how small a hummingbird is as compared to the size of an ostrich, the emu is right up there with one of the biggest birds in the world. But when we're talking about the giant moa, you're talking about something that is at least 2 times the size of an emu.
Yeah, that's right.
So we wouldn't be feeding them like this, it would be like this.
That's right, yeah. Female South Island giant moa were over 12 feet tall.
Wow, it's crazy to think about something twice this size. And it's like you're looking right into the eyes of a dinosaur. So curious. When it's got its beak open like that, look at
The ridges.
At the ridges
Yeah,
on the beak.
yeah. That helps it cut plants as it's eating them.
Okay, so these guys are primarily herbivores as well.
Yeah, they'll also eat insects.
Okay, so that would technically make them an
Omnivore.
Okay.
Yeah. And moa were herbivores. They probably picked up some insects because with as large as they were and as much plant material as they were taking in, they would be getting insects with that as well.
So bugs kind of come naturally as you're eating plants.
Yes.
Now, when you guys have de-extincted the giant moa, bigger bird, ooh, it's biting the back of my head. Bigger, I do have a green bandana on, so it probably looks like kale. Bigger bird, bigger food. What will the giant moa be eating?
Giant moa, it ate all kinds of plant material. It would even eat twigs off of bushes, berries.
Twigs like sticks?
Twigs like sticks.
Is that for fiber?
Yeah, that would be a good source of fiber.
Okay. You think I can Lady in the Tramp this emu? Oh my God, I can't, this is amazing. Think I'm the first person in history to Lady in the Tramp an emu? No, yes, Anna?
I think you're the first.
Okay, thank you. And this is a cool opportunity. I really want to touch your wings. Is that cool? They do have wings, which the giant moa did not, correct?
That's right. That is one of the unique things about moa is that they had completely lost the wing structure. So there are no forelimb bones at all. But emu...
I'll block my eyeball just in case. Yeah, you can bite my arm. Yeah, oh my gosh, look at this little wing right here.
Yeah.
Oh, I touched the wing. That's so cool. So, okay, if you're gonna modify the genetics of the emu to make a giant moa, are these giant moa gonna have little tiny teeny wings?
No, we'll completely remove the wings.
You can do that. You can choose like no wings for you.
Yes.
Come on, let's try to get close to the feet. Don't worry, I won't let you get kicked. Oh my gosh, the feet are so cool. So the giant moa has got that 4th claw that comes off the back that really makes it look like a T-Rex.
Yeah.
But will you guys also genetically edit out that claw as well? Or will your giant moas have more smooth back ankles like that?
We are planning on putting the we're planning on putting the claw back in.
That's what it looks like when an emu literally poops inches. I mean, this is 2 feet. We'll call it 2 feet. That's why you don't get behind the emu. Oh, wow. Yeah, no, it doesn't smell great either. Okay, emu diarrhea. Now we've seen it. Are yours going to do that too, the giant moas?
Yeah, they will. They'll make kale smoothies.
All right, well, moving on past the dump pile, as Dr. Ian Malcolm would say, that's one big pile of, you know how the rest of it goes. Okay, so we were talking about the feet. I mean, nothing is more dinosaur looking than the feet.
The feet are amazing.
Of an emu or a cassowary.
Yeah.
And when we start thinking about Colossal, you guys are able to genetically edit the chromosomes, essentially, correct?
Yes, yes.
And you can make a giant moa, but how visually will that compare to the emu? Are you going to be able to change the color, the foot structure, the feather structure? Let's talk through some of those things, because these are already super unique looking, so you're not going to just make a supersized emu.
No.
It's going to have more characteristics of the giant moa.
Yes. Size is really important, and that's going to be a challenge to do that, but that's one of the things that we'll focus on first, and then we'll also go after some of those other traits that you mentioned. Really making the legs more robust, the neck more robust, the jaw shape was slightly different. South Island giant moa had a slight down curve to its beak.
So the emu has blue skin, and I remember the cassowary being also very similar. At least the blue is in the neck. It doesn't look like it's so much blue down here. But when we're talking about the giant moa, do we know what color they were? Are there actual giant moa bodies that still exist?
There have been mummified bodies that have been found of some of the species, and we have feathers. The Maori, the indigenous people of New Zealand, used bones and feathers from the moa, and so we still have some of those today. So we know, some of them were a little more red, some of them a little more brown, but we do have that information on the color.
I just love looking at them and watching them. There's just like looks like a little mop on top of a pair of stilts or dinosaur feet.
They're so fluffy. I want to get in there and touch them again.
Okay, let's go hug them. That's a nice bird. Look at this guy. I'm gonna
see his wing?
For scratchies. Okay. Yeah, okay, see if you can get the wing. See if you can get the wing before I get kicked. You feel the wing in there? Or is it tucked all the way in my head?
Yeah.
Okay.
So this is the wing.
Wow,
it's
look
really
at it.
Small.
Teeny tiny wing. Ah!
Such a giant bird.
They'll only let us touch the wing for a second. Even when you're scratching their backs and they love that, they're like, no, not my wings. I mean, if I had wings that were that small, I'd probably be a little embarrassed too.
But they don't need them. They're such fast runners.
Yeah.
They run to get away from predators.
I heard they clock the emu at speeds of close to 30 miles an hour.
Yeah, that's right.
Significantly faster than you or I.
Yes.
So, when we're talking about bringing back the giant moa, I think the big question that everybody's going to have is why?
Well, moa were a really significant, culturally important bird, and they also served a really important role in the ecosystem. There were no native mammals in New Zealand other than bats. So the birds in New Zealand evolved to fit all of these different roles in the environment that would normally be filled by mammals.
Okay, so the fact that they're gone now, has the environment been negatively impacted over the past few hundred years?
Yeah, native New Zealand plants are negatively impacted by the loss of the moa.
Interesting. So to think about the fact that we're always working to conserve animal species, but we don't oftentimes think about the plants that also need conserving and brought back.
It's the whole picture. It's the whole environment is important, and that ecosystem is a web, and you take a piece out of that web and it's possible that the whole thing can collapse.
Okay, so you guys are going to be using the emu as the genetic blueprint to bring back the moa, but could an emu plop out a moa-sized egg?
No, it cannot, but it at least gets us an egg that's somewhat closer than some of the other ratite species would.
Whoa! Wow! The emu egg. This is a non-fertilized emu egg, but there is real emu materials inside of here.
There's yolk and
albumin and
yes.
And when we're talking about this in comparison to the giant MOA egg, they don't even compare.
Yeah, I mean, giant MOAs.
Wow.
Yeah, much, much bigger.
Okay, so why does the emu egg make such a great vessel early on in the process of bringing the MOA back from extinction?
Well, it's not as large as we ultimately need it, but it's large enough that it'll get the process of embryological development started.
Okay, so the egg will work then as a vessel to carry a baby MOA, but can it come all the way to term inside of that egg?
No, it wouldn't come all the way to term inside of that egg, but it can act as that biological egg surrogate and get it started.
So we're looking at the physicalities between the emu and the giant MOA in the field. Now we're here in the lab. How does this all tie together? Because these eggs are of such different size.
We start with the emu.
Okay.
Because we do our edits in bird cells, and then those cells have to get back into a living bird to do their thing.
Okay.
So we start with some bird cells, we make our edits, those things that give the MOA its specific traits, and then we put those back into an egg whose own germ cells have been removed. And the germ cells...
So it's kind of like a neutral egg at that point.
Exactly.
Okay.
It's a kind of a blank vessel to put our edited germ cells in. And germ cells are the cells that will form eggs and sperm in an adult bird, right? That's what's going to pass information on to the next generation.
Wow. Okay, let me walk this back for a second. So you're going to have a genetically modified pair of emus that are then capable of being able to carry edited genetics to look like a MOA.
Exactly.
How did you guys figure this out?
It's been done already in chicken, actually, and today we're going to show you how we do it with the chicken egg.
Got it. Which will then form an egg and hatch a chicken that has these modifications.
That's correct.
Which will eventually tie together between a genetically modified emu to get us here.
That's right.
But this is so much bigger than this.
It is, but this is where we need to start because this is the living bird that we have that can carry those germ cells.
Interesting.
And then later down the road, Dr. Pask is going to tell you how we get from this to this.
All right, so I'm assuming sitting right over there is Emily, who's already got those eggs out on the counter. Is that where I go next?
That's right. We'll head over there and Emily will show us how it's done.
So I'm going to be showing you how we reintroduce our edited germ cells that Anna was talking about, those precursor to egg and sperm, back into an embryo. And at this point in development, those cells that we're interested in are circulating through the bloodstream. That's something every living creature has these germ cells, but avian birds are unique in that they go through the bloodstream to get to where they need to be.
And you're going to use the microscope to be able to look inside of that egg to make this injection.
Exactly.
Now, you don't have to answer because you have the aspirator in your mouth, but I'm assuming you're using a little bit of air from your mouth to be able to then push that dye into the chicken embryo.
I am.
Wow.
So you can see,
whoa, it
as
all
the
just
heart
changed
continues
color.
to beat, it pushes the dye and our edited cells through all of the vasculature.
That's wild. And now what has that essentially done? You've put edited cells into this 3-day-old embryo and it will alter the future of this chicken in what way?
Yes, so the cells that we've injected will make their way through the vasculature and settle in the gonads. And so when this chick hatches, its egg and sperm will be from these cells that we have edited. So when we replicate this in emu, they will have the edits that it needs to be a MOA. So you will have an emu that can give birth to a MOA chick.
And just to reiterate, the chicken is sort of the practice step. And I know that for everybody watching, this pertains more specifically to the dodo, but you also do this process with the emu. So you will do this process on a much larger emu egg the same way you're doing it with a chicken.
Exactly.
But even still, once you've got those edited cells inside of an emu egg, you can't grow a full giant MOA inside of an emu egg. So what do you do there?
Well, that's where Dr. Pask will tell you our giant plan for the giant MOA egg.
So Dr. Pask, what happens here in the Exo Dev Lab?
So the ExoDev Lab really works on devices that can support embryo development outside of either the womb, in the case of placental mammals, a pouch if we're talking about marsupials, or artificial eggs if we're talking about birds. So what you're looking at here are all the different models that we made of artificial eggs. And this is the one that we have actually used now to successfully hatch a good number of chickens from this artificial egg.
So you guys have hatched chickens from this artificial egg?
Right, so what we do is we collect freshly laid eggs and we can put them into this device, and then we put these into an incubator, we supply them with all of the oxygen and other requirements that they need, and then that can support the development and growth of that chicken all the way up until hatching, until you have a live little bird.
Now, I'm holding this. I'm sure everybody's wondering, well, Coyote, what's it made out of? It's plastic. How did you create this?
Yeah, these are 3D printed plastic polymers that you can use to make these artificial eggs. But then when we actually want to put the egg inside it, we have to line the cavity there with a very, very thin membrane.
I see that. Okay, that might be hard to see on camera, but you're right. There is a thin membrane on the inside of that. That just looks like saran wrap or something. How thick is that?
Yeah, this is an ultra thin membrane that has to be ultra thin so that it can enable gas exchange to happen across it and also keep the moisture in for the embryo. So that's a really, really important role. But this one here is about 20 microns thick. So that's about 1/5 of a human hair in terms of its thickness. So really thin to enable that gas and moisture to exchange.
And you know, they're always talking about what came first, the chicken or the egg. And we know when you go back in time and you look at dinosaurs, it's like, well, dinosaurs had eggs and there were dinosaurs before chickens. But when it comes to modern times, in this instance, it truly is the egg that has come before the chicken.
It has.
And when we're talking about the evolution upward, I see that you've got the emu egg there. We've got an ostrich egg, and then we've got a supersized artificial egg. And I can only imagine what this is going to eventually house.
So this is the artificial moa egg.
Wow, it is massive. Look at that thing, guys. And with a membrane inside here, then you guys will be able to successfully take the edited sequence, the cells from what is developing in an emu egg that has all of the genetics of the moa, put it in here, and successfully incubate the first giant moa.
And that's exactly why we needed to develop the artificial egg, is because there isn't currently a bird that lays an egg big enough to gestate a moa. So we had to work on a device where we can figure out exactly how to get this to work and then scale it up so that we can eventually hatch our baby moa chicks from this device.
Right.
And we can actually watch that whole process happening in the artificial egg as well.
Unbelievable. And you guys may not realize this looking at it, but this is quite the advancement in biological technology.
Absolutely. Like, this is something that we've really precision engineered so that we end up with really healthy birds that come out of these devices. But this unlocks a whole host of new biology now that we can do for bird species, critically endangered bird species, as well as bringing back bird species that have gone extinct.
Right, because it's not just about bringing a giant moa back to life. It's about the future conservation of species that are on the brink of disappearing. California condor is a great example of a very large bird that was pushed to near extinction and are still facing major threats with lead poisoning. And now we've got a way to ensure that not only bird species, as you said, but also some mammal species and marsupials, by being able to create artificial wombs, will never disappear off the planet.
Exactly right.
Wow, that is so crazy. So do we have a timeline, or can I ask, what is the timeline for bringing a giant moa back to life?
I don't think we have clearance for that. We'd have to kill you, Coyote.
Okay, well then we won't necessarily reveal that yet. Any timeline for when we're going to see this giant bird come back to life?
It's a very good question. You'll have to subscribe to Colossal's YouTube channel to get all of the latest updates on when these species arrive.
All right, well, I personally can't wait to be able to see one of these giant birds in person. Thank you for having us into the Exo Dev Lab today. There you have it, guys, the world's most advanced artificial egg. Never thought I'd be hands-on with it, and I can't wait to meet the giant moa. I'm Coyote Peterson. Be brave, stay wild. We'll see you on the next adventure.
What are you doing?
I'm trying to like look like a tree.
I'm gonna zoom out here. Where is Coyote? See there? No. There? No. Oh, there he is!
Look at the bird. The bird is looking at me. This is gonna work. I'm telling you, it's gonna. If we could just get the bird to like eat the kale like this, like a thumbnail.